The topic is interference in thin films. So in the sixth chapter itself, we studied clearly regarding the rarer medium to denser medium and denser medium to rarer medium. So first, the rarer medium to denser medium means, okay, the ray will bend towards the normal. From denser to rarer means the ray will bend away to the normal. Okay, so this is the thing we studied in the sixth lesson. So now we know what is interference. Okay, so intersecting of two rays, okay, or crossing of two rays. So here also the same thing is happening here. So first, so take one thin film. Okay, this is the thin film. Okay, so this is the distance d, which means the ray passed through this film will have the distance d, which is nothing but the path difference. Okay, d stands for the path difference. Okay, so now I will have the incident angle here, because this is the incident light, incident ray, this is the source of the ray. Okay, so here I have the incident angle, so and here I have the reflection and also the refraction. So this is refraction and this is reflection. So from this you can easily understand by the diagram itself that you have the reflection as well as refraction in this topic. Okay, so watch this fully, then only you can able to understand. So the incident light, when it touches rarer medium to denser medium, the thin film is a denser medium, so this is the rarer medium. So rarer medium to denser medium, so this is the perpendicular line, okay, normal line. Okay, here the ray is bent towards the normal and also I am getting the reflection. Okay, rarer to denser, the ray will bend towards the normal and this is the reflection. Okay, both reflection and refraction is taking place here. Again, when it comes to the end of the denser medium, again it has the denser medium to rarer medium. So here I have the away from the normal, and also the reflection takes place as well as the refraction takes place. This is the reflection and this is the refraction. Okay, so the same thing for the next thing also. So then this ray will go to this converging lens. These two are converging lens and I will get the result here. Okay, I will get the result P dash and P, okay, in both sides. So this is the converging lens. Okay, so again this goes here. So afterwards, so this is from denser to normal. Okay, so denser to normal means again this ray will go like this and some will get, okay, refracted. Again this ray will go from here to here, again it will come like this. So this like only will happen here. Okay, so then we'll move into the topic. So for the transmission, okay, for the transmission, okay, so before that we need to find out the path difference. So path difference is nothing but the way the ray travel or the distance. Okay, so here I have the thing B and P. Okay, B and P. I'm taking the point B and P and I'm going to take only these two lines. Okay, I'm going to take only these two lines on both sides. So I'm taking here B and P. Okay, so I'll write here for transmission. For transmission, BP, okay, and this is the path difference. Okay, BP is the path difference starts from here, B and P. Again, I'm taking the here the ray is refracted and the ray is reflected. The ray is reflected. The incident ray is refracted from B to P. Again, this ray is not coming to this second point. Okay, in the converging lens, I have the again second line. No, for this here the ray is reflected. So here I have to take the angle B, and so I didn't mark it. So A, C, E and G. Okay, so here B, C, D, P. Okay, I'm getting the second line. When this ray, the incident ray is reflected, I'm getting the second line. Okay, when this ray is reflected, this is refraction for the incidence and this is reflection for the incidence. Okay, so I'm getting the second ray when it is reflected. So I need to take B, C, D, P. Okay, so I'll write here B, C, D, P. Okay, so first we should know what is optical path. So optical path is nothing but the reaching time will vary. Okay, for example, when I pass the light source in the vacuum, the light will have the much speed, which means high speed it has. Okay, so when I pass the light source, okay, with when I kept some materials in some medium, so when I make the ray to pass on that way, so I will have little bit time difference when I compare to that the vacuum medium. Okay, so that is called the optical path, but it reaches the same point. Okay, so I will have the time variation. Okay, so here the d dash is nothing but the path difference. D dash is nothing but the path difference. So I have the formula here, n lambda for the constructive. Okay, for the constructive rays I have the formula d dash is equal to n lambda. So here we are going to take the d dash is equal to 2 mu d. Why 2 mu d means we know that one ray has the distance d and 2 ray means it has 2d. Okay, so I am writing here the space, the permeability of free space and the distance is 2. So I am mentioning it with 2d. Okay, so I can write 2 mu d, or I can write mu 2d. Okay, anything I can write. Okay, so 2 mu d. So now I have this formula. So we'll substitute this in this. 2 d dash is equal to what? 2 mu d. So 2 mu d is equal to n lambda. So this is for constructive interference. Constructive interference in the sense will have the 0, pi, 2 pi, 4 pi, like that we will have. Okay, so here we have the path difference like this. So when I take for the destructive, so this is for the case transmission, yet we didn't reach the topic reflection. This is only for the transmission. So here I have destructive interference. So for that also I know the formula already we studied in the previous topic, 2 minus 1 lambda by 2. So here also the path difference will be same. Okay, path difference will be denoted by the symbol del. Okay, so here I have directly written d dash is nothing but the path difference. So I can write the del here. Okay, so destructive interference means, so again here also the same thing only, because the path difference is 2 mu d is equal to 2n minus 1 lambda by 2, and multiply this lambda with this inside bracket term. So I will get 2 n lambda by 2 and minus lambda by 2. Okay, so here this 2 and this 2 will get cancelled. Okay, so remaining I will have n lambda minus lambda by 2. Okay, I can write this equation as, take lambda as a common. So I will have n minus 1 divided by lambda 2. Okay, n minus 1 and divided by 2. So this is the thing for the constructive interference. So now constructive and destructive interference in the transmission. Constructive and destructive interference in the transmission. So now we'll see for the reflection. Okay, for reflection. So reflection we are going to take this A and P. So the reflection starts here only. For the incidence, the reflection starts here only. For the transmission only, the reflection starts here, because the refracted angle and then only the reflections. But here the incident directly goes for the reflection here. So the reflection will be A P dash. A P dash, and what else? A, again the refraction takes place. Here for this reflection, A, B, C, P dash. Okay, listen carefully. A, B, C, P dash. Then only I will get the second line in this converging mirror. Okay, lens. So I will write A, B, C, P dash. Hope you will not have any doubt. So here also the same thing, only the distance will be 2 mu d. Okay, here also the path difference is equal to 2 mu d. Okay, so and one more special case we have here, the angle between the normal and incidence is 0, the length will decrease. Okay, so the angle between the normal and incidence is 0, which means if I don't have any angle here, the line will come closer to this place. Okay, the line will come closer to this place, and now we'll apply the same thing in the formula. So what will come for the constructive, for the reflection, will have 2 mu d is equal to n lambda. The same formula, d dash is equal to n lambda formula. So I will be writing path difference as 2 mu d is equal to n lambda. Okay. So here the angle will be what? Lambda by 2. Okay, so I'll write lambda by 2 is equal to n lambda. I'll tell you. Okay, 2 mu d plus lambda by 2 is equal to n lambda. Okay, so here I can change this equation as 2 mu d, okay, is equal to n lambda. Take this plus lambda 2 to that side, so it will become minus lambda by 2. Okay, so again I can reframe this equation. 2 mu d is equal to n minus 1 by 2 and take this lambda as a common. Okay, take the lambda as a common. Okay, and this case is for what? Constructive. So again I'll have the destructive here. Okay, so here also the same distance only. So 2 mu d plus lambda by 2 is equal to, okay, the same thing. Okay, 2n plus 1 lambda by 2. Okay, 2n plus 1 lambda by 2. So this is for destructive, because we saw this equation in the previous topic itself. N lambda is for the constructive, 2n plus 1 minus 2n plus 1 lambda by 2 is for destructive. So now I can write this equation as, listen here, 2n multiply. Okay, so lambda by 2 plus lambda by 2 I will get here. So here 2 mu d plus lambda by 2 as it is. Okay, so here this 2 and this 2 will get cancelled, and this lambda by 2 and this lambda by 2 will get cancelled. So I will have 2 mu d is equal to n lambda. So here you can see one thing clearly. For the reflection, I have the destructive as 2 mu d is equal to m lambda. But for the construction, I have what? The same thing. 2 mu d is equal to n lambda. For the constructive, 2 mu d is equal to n lambda. Okay, so there the constructive is what? 2 mu d is equal to m lambda. Here the destructive is 2 mu d is equal to n lambda. Okay, so this is what interference. If you have any doubt, just tell me, I'll clear you that. Okay, thank you.